Welcome to Tutor Beta Math. Changing the subjection equation. First of all, we need to define the term subject. In this equation, b equals 3c plus 2, b is the subject because the equation starts b equals. To make c the subject, we need to rearrange the equation to start with c equals. In the following, let's make x the subject of the equation. Let's start with a really easy one. Y equals x plus 4. We want to rearrange this so that it starts with x equals. We're going to use the balance method to move the terms in the equation. In the balance method, we make sure that we do the same thing to each side of the equation to keep it in balance. In this particular case, you can see that we've got plus 4 with the x. So what we need to do is get rid of that 4 to put x on its own. And we do that by doing the inverse process of add 4 or plus 4, which is subtract or take away 4. So if we take away 4 from each side, we get y minus 4 is equal to x. If we turn it round, swap sides, we've now achieved our objective and x equals y minus 4. Looking at the next one, y equals 5x. 5x, as you know, means 5 times x. To get x on its own then, we have to do the inverse process of times or multiply, which is divide. So we need to divide each side by 5. When we do that, we get y over 5 equals x. Notice that we don't use the divide sign in algebra. We use the fraction form for division, remembering that the line in a fraction means divide. Again, as is usual, x is at the wrong side of the equation, so we need to swap sides to get it exactly as we need it. X equals y over 5. Look at this one. Y equals x over 3. As we've just said, x over 3 means x divided by 3. So to get x on its own, I'm going to do the inverse process. The inverse of divide is multiply, so I'm going to multiply each side by 3. And that's going to give me 3y equals x. Again, swapping sides, x equals 3y. And the next one, y equals 2x minus 3. In this one we've got two stages to process. The first thing we want to do is get 2x on its own and then get x on its own. So to get 2x on its own, we're going to do the inverse process. So minus 3, we're going to change the side for that, we're going to add 3 to each side. We get y plus 3 equals 2x. Now, like the one opposite, we've got 2x, so we need to divide by 2. Notice everything on the left-hand side of the equation has to be divided by 2, so the line is under y plus 3. And it's y plus 3 all over 2 is equal to x. Again, swapping sides leaves it like that. Looking at this one, y equals x over 2 plus 5. Again, a two-stage process. So first I'm going to take away 5 from each side to get y minus 5 equals x over 2. Looking at the earlier example, x over 2 means x divided by 2. So what I'm going to do is I'm going to times each side by 2. When I do that, I get x on its own on the right-hand side, and on the left I get 2y minus 10. Notice I have to multiply everything on the left-hand side by 2, which is why I get 2y and minus 10 is equal to x. Turning it round once more, I get the answer I'm looking for, x equals 2y minus 10. Let's look at some more examples. In the following examples, squares or square roots are involved, and sometimes factorisation. Let's have a look at one or two. We're going to find v in this one. E equals a half mv squared. So what we're going to do is I'm going to get rid of the half by multiplying both sides by 2. So 2e equals mv squared. I'm going to get v squared on its own by dividing each side by m. So 2e over m is equal to v squared. But I want v to be the subject, so I need to square root each side. First of all, I've turned it round so that v squared is on the left, and when I square root it, square root of v squared is v, and the square root of the right hand side is simply the square root sign around all of 2e over m. So you could write that as square roots brackets 2e over m to make sure that it's understood what it means, but the way that's written there, where the line is over the top of the 2e, tells us that it's the square root of all of that item on the right hand side. Let's have a look at the next one. This one's got a square root sign already, and we want to make b the subject. The first thing we have to do is get rid of that square root sign, and we do that by squaring both sides. So t squared, obviously, is equal to square root of something squared, gives you what's in the square root sign, which is b plus a over g. So off I go with this. b plus a is all divided by g, so the first thing I want to do is multiply each side by g. So I get gt squared is equal to b plus a. Now when I take a from each side, I get b on its own, so I've got gt squared minus a is equal to b. Swapping sides, I end up with b equals gt squared minus a, which is the answer I'm looking for. Next one involves factorisation. In this equation, I want to find x. If you look carefully, you'll see that I've got x on both sides of the equation. So what I need to do first is to collect all the x's together and then rearrange to find x equals. So let's have a look at how we do this. The first thing I've done is take dx away from both sides. So I've got cx minus by minus dx is equal to minus ay. I can add by to each side so that I get 2x terms on one side, which is what I'm looking for, and everything else on the other side. So I get cx minus dx is equal to by minus ay, because I've added by to each side. Now on the left hand side you can see that I could factorise that. I can make it x brackets c minus d is equal to by minus ay. So I'm nearly there, because all I need to do now is divide by c minus d, and I've got by minus ay all over c minus d is what I'm looking for, equal to x. Now I could factorise the top of that, taking y outside the bracket and making it y bracket b minus a all over c minus d. Thank you for watching.